How's it going? How's it going, everyone? Welcome, Eulier again. Today, looking at the observables, and this interesting topic, especially on the reactive programming, and it is useful when you're developing user interfaces that, at the end of the day, as UI specialists, we always tend to deal and manage all of these events that can happen from the user, from the server, and there's events everywhere. Now, the idea of this is to answer these questions. How can we now handle these streams of data from a source so we can now apply to each one of these units is or we can pass through some series of steps or transformations and then distribute that in our application. And that's where we're going to take a look at today's video. So, this is a course taught by Kyle Simpson. So shout out to Kyle Simpson. Software engineer that currently he's working at Vela.ai. And well, the idea is to get a more hands-on practical approach of this. Let's get into this.
Enter observables. Now, understand that.
So what I'm going to do is just taking notes out of this course, so you're not able to see that, and then jumping later on to the code to actually see how can we create that.
Observables are not a guarantee for JavaScript. Right now, they are implemented in userland libraries, and there is a proposal for.
So right now, they are not guaranteed. Okay, 2024 in JavaScript language, but there is a proposal that is based on specific libraries out there that implement this kind of behavior. So for example, we have now the observables here in proposal from the T39, that's right. Observable as a proposal 9 years ago. That's interesting. Not even sure if they still exist. That's quite interesting. Let me see if I take a look at the proposal here. Stage 1 draft, January 10, 2017. The observable constructor. Again, this is a draft, by the way. Okay. But there is a proposal for that.
Observables to land in the language. At some point.
Okay. But there is a proposal that is based on specific libraries out there to land on the language.
There was a strong feeling like they might land in the ES7 timeframe. As far as I'm aware, I don't think that's actually going to happen in ES7, meaning ES 2016. Because as far as I'm aware, as of today, I think the feature cutoff for ES 2016 is like next month. So observables are on a good path, and there's a pretty good chance we're going to get something like this natively in the language. It just might not be next month. So it might be a little bit further off. And that means that what we're about to learn with observables, we're learning based upon the semantics of a particular library implementation. We don't have a very good sense of exactly.
Mm-hmm. So here we're going to see is a library that might follow the spec of observable in the long run.
What they're going to be from a native primitive perspective, like we did with promises. So the caveat here is the sorts of stuff that we're about to talk about is subject to some flux. It's subject to some evolution between now.
Okay. So the caveat here is that this is something that will evolve, that is in this state of flux.
Now in the time that some final standard lands, observables may end up being called something different. They might have a different looking API. Who knows? But right now, there's a pretty good library out there for observables, and it's called RxJs. That's our JavaScript library. It's actually, Rx is the name of the library, Reactive Extensions. It's made by the folks, really smart folks at Microsoft. And they've ported it to like a dozen or a couple dozen different languages. So RxJS is the JavaScript port. It's in C#. I think that's the original one. It's in Java. It's in several other languages. So it's nice from the consistency perspective. Whatever language you work in, there's probably an Rx library for it. Once you learn it once, you're going to be able to use it in lots of places. That's good. But to understand what an observable is, again, from a conceptual perspective, see how this is how I always teach. I'm not going to teach you the API first. I want to teach you the conceptuals. So let's talk about spreadsheets. Everybody loves spreadsheets, right? I just found some random spreadsheet image on Google Images because I didn't have any good ones to take of my own. I don't know what this spreadsheet is, but it's pretty clear that this spreadsheet is illustrating the concept that I want to get across. By the way, this metaphor is not unique to me, so I've heard this from others. I just think it's a particularly good one to start with.
Expressing the concept.
An observable is kind of like a chain of calculated fields in a spreadsheet. So
an observable is kind of like a series of chain of computation.
A good one to start with. An observable is kind of like a chain of calculated fields.
Okay. An observable is kind of like a chain of calculations.
A chain of calculated fields in a spreadsheet.
Chains of calculated fields in a spreadsheet. That makes sense.
So, you know, in spreadsheets, you can have data in a field, but you can also have a field which is a calculated field.
Mm-hmm. So in a spreadsheet, you can have a value in a field, but also
Chain of calculated fields in a spreadsheet. So, you know, in spreadsheets, you can have data in a field.
Okay. So in a spreadsheet, you have data in a spreadsheet. Let me actually is. So you have data in a spreadsheet, but also calculated data.
But you can also have a field which is a calculated field.
But you can also have a field which is a calculated field.
It's calculated based upon the data that's in some other field.
So it's calculated based upon the data from another field. From another fields.
So C1 might have the number 10 in it, and C2, right below it, might be whatever value is in there times 2.
So C1 have a value of 10 on it, and C2 have a value of C1 plus 10 plus 2. And C2 has a value of this. Make this cloth. What's the difference between has and have? I have. Oh. Has is used with third person singular object. Third persons. He, she, and the dog has. Okay, C1 has. Okay. C1 has that. And James has finished his work. Third person. Has finished. Have is used with first person, second person, third person plural. I have. I have. They have. You have. Okay, has and have. Okay. So C1 has a value of 10 and on it, and C2 has a value of C plus 1. That's right.
So when I type in 10, then as soon as I hit enter, immediately this field says 20. And I might have another.
So when I hit enter, as soon as I did, it will get immediately the value calculated which is 12.
Other field over here, I might have D13 that says D13 is the calculation of 3 times whatever's in C2.
And then I have another field D3 that say, hey, this is the calculations of whatever is on C2 times 3.
So I change this to 20. C1 becomes 20, C2 becomes 40.
So C1 is 10, C2 becomes 2. Exactly. So C1 becomes, so C1 is 10, C1 is 10, C2 is 12, and C3 is 36.
And D13 becomes 120, right? Do you see that the calculation chain is a flow of data?
C1 is 10, C2 is 12, all right, and then C3 is 36.
We're setting up the calculation chain is a flow of data.
You see the calculation. You see the calculation steps is a flow of data.
We're setting up a flow of data from an original source location to all these different places where we're doing something with that data, we're calculating something.
So we are doing,
Something we're subscribing to and responding to that data. That's the genesis of this notion of to all these. The calculation chain is a flow of data. We're setting up a flow of data from an original source location to all these different places where we're doing something with that data, we're calculating something, we're subscribing to.
Okay, so we're doing a flow of calculations data from the source of this data and from the flow. So we're doing a flow of calculation of data from the source of this data and doing a series of calculations. So a series of calculations.
To and responding to that data.
To a series of calculations to respond on that data. This is the genesis. This is the genesis of reactive or observable.
That's the genesis of this notion of reactive programming. When we think about
This is the genesis of reactive programming.
Reactive programming, it is to say, the source of my data is some event source. But the data, once I get that event, it's going to go through a series of steps. And some of those steps are going to be direct, like responsive, just calculate something. And some of them might be asynchronous steps. The calculation of the data that goes through the spreadsheet as you change one value, even though it looks immediate to us, each step it has to update all the fields and then update all the fields and then update all the fields. So there is some propagation delay, if you will. But we can think about an observable, or rather reactive programming, as a way to model a piece of data coming in one side, that's from the producer. You can think of a step, it has to update all the fields, the steps, and some of those steps are going to be direct, like responsive, just calculate something, and some of them might be asynchronous steps. We go through a series of reactive programming. When we think about reactive programming, it is to say, the source of my data is some event source.
So the source of my data is the event source.
But the data, once I get that event, it's going to go through a series.
The source of my data is the event source. But the data, once I get that, the source of my data is the event source. But the data, once I get that,
series of steps. And when we think about reactive programming,
it's
it's
going to pass
say,
through this series
the
of
source
steps.
of my data is some event source. But the data, once I get that event, it's going to go through a series of steps. And
But the data, once I get there, once I get that is going to move.
Data, once I get that event, it's going to go through a series.
It's going through. But the data, once I get that, is going through a series of steps of calculation.
Series of steps, and some of those steps are going to be direct, like responsive, just calculate something, and some.
But the data, once I get that, is going through a series of steps that some of them might be immediate response.
Some of them might be asynchronous steps.
But some of them might be immediate response. And some of them might be asynchronous steps along this change.
The calculation of the data that goes through the spreadsheet as you change one value, even though it looks immediate to us, each step it has to update all the fields and then update all the fields and then update all the fields. So there is some propagation delay, if you will. But we can think about an observable, or rather reactive programming, as a way to model a piece of data coming in one side, that's from the producer, the event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system.
And all
it's a data flow mechanism.
And data flow mechanism it is system, and this is something here. So an observable. So as UI, especially, we need to deal with events from the user, the server, animation, storage. So an observable is a way to model the need to receive a single data from an event source. Okay.
The event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system.
And all the steps that it passes. And all the steps that it, in all the step
system. That's from the producer, the event emitter, if you will, coming in one side, and all the steps that it takes to propagate its way through a system.
And all the steps to propagate it is a way to the system. Receive a single unit of data from the event source on event emitter, if you will, and all the steps to propagate it is way to the system.
It's a data flow mechanism. And data flow mechanisms are built.
A data flow mechanism. And as you can see, if you think about that, for example, with promise and with generators, this is now a data flow mechanism. But with promise, it's pretty much descriptive. You have now this data flow mechanism, similar to the thunk, which is a little bit more abstract, but you have now this data flow in the context, and with thunks and promise, you also have this data flow mechanism and the change of mechanism. Or the data flow mechanism and the data flow mechanism, and what's next? The data flow mechanism and the Jesus, what the fuck? The data flow mechanism and the flow control.
From the ground up to respond to events. So if we've got event-oriented systems, this might be a really good abstraction for us. Does everybody follow where I'm coming from conceptually?
So if we have event-oriented environment,
from the ground up to respond to events. So if we've got event-oriented systems,
So if we got an event-oriented system, this might be a good pattern to go with.
This might be a really good abstraction for us. Does everybody follow where I'm coming from?
This might be a good abstraction.
So let me boil this down for you. An observable is an adapter hooked on to an event source that produces a promise every time a new event comes through. But it does so in that separate way where I can set up my event source, and an entirely different part of my location, I can declaratively say what's my data flow. I don't have to conflate the two like we were doing in those other examples where I put the promise inside of the event thing. I have an observable that represents my data source, and I can subscribe to that observable in one or more other locations of my system in an entirely separate way. And it's going to magically take care of all that creation of promises and the bridging the gap for us. So it's a way in programming to represent what we can visually think about or conceptually think about from a spreadsheet. We can represent each one of those different fields as a different step in a chain of response to an observable. So here's a quick example of some code from RxJs. You'll notice that you create an observable source, and I can subscribe to that part of my location. That produces a promise every time a new event comes. So let me boil this down for you. An observable is going to be a really good abstraction for us. Does everybody follow where I'm coming from conceptually? So let me boil this down for you. An observable is an adapter hooked on to an event source. Oriented systems, this might be a really good abstraction for us. Does everybody follow where I'm coming from conceptually? So let me boil this down for you.
So we'll boil this down for you. So let me boil down for you. Let me boil this down for you. Let me boil this down for you. Boil. Bring to the boil. Let me boil down. Boil down. Boil something down. Let me boil down for you. Boil down. Boil down. Reduce the volume of liquid by boiling. Or condense, exactly. Boil down. So let me boil down for you. So let me boil this down for you.
An observable is an adapter hooked on to an event source.
Okay. It's an adapter. So an observable is an adapter. Hook up, hop up, hook up, hook up, hook onto. Okay, an observable is an adapter hook on onto an event source that produces a promise.
That produces a promise every time a new event comes.
That produces a promise anytime an event, anytime or every time. Exactly. Every time an event an event comes through. Every time a new event comes through. A new event comes through. So it's an adapter hooked into the event source. Hooked into an event source that produce a promise every time a new event comes through. So hey, if there is an event, I hook up to the event source to produce a promise. I hook up to event source and produce a promise. When any events are coming through, hey, I produce a promise. I produce a promise. I produce a promise. I produce a promise. Mm-hmm.
But it does so in that separate way where I can set up my...
But it does in a separate way that I can set up my observable and hook up to the source,
my event source,
where I can set up my, but it does in a separate way that I can set up my event source and then the consumer.
And an entirely different part of my location, I can declaratively say, what's my data flow?
And in an entirely different location, I can declaratively say what's my data flow.
I don't have to conflate the two like we were doing in those other examples where I put the promise inside of the event thing. I have an observable that represents my data source, and I can subscribe to that observable in one or more other locations of my system in an entirely separate way. And it's going to magically take care of all that creation of promises and the bridging the gap for us. So it's a way in programming to represent what we can visually think about or conceptually think about from a spreadsheet. We can represent each one of those different fields as a different step in a chain of response to an observable.
So this is a way, so this is a programmatic, way to describe, so this is a programmatic way to describe the spreadsheet.
Visually think about or conceptually think about from a spreadsheet, we can represent each one of those different fields as a different step.
So this is a programmatic way to describe a spreadsheet.
So it's a way in programming to represent what we can visually think about or
So this is a programmatic way to represent what we can visually think about a spreadsheet.
Conceptually think about from a spreadsheet, we can represent each one of those different fields as a different step.
So we can represent each different field with each different steps. Exactly. A good analogy here. So we can represent each one of those different fields. So we can represent each one of those. So we can represent each different field with as. So we can represent each different fields as different steps.
in a chain of response to an observable.
In a change of response to observables.
So here's a quick example of some code from RxJs. You'll notice that you create an observable using rx.observable.fromEvent. That's one of their many utilities they provide. And the way it's set up is it takes a DOM element and an event name. It automatically hooks the event name to the DOM element, and every time one of those events fires, it pumps another piece of data through the chain. Set up is it takes a DOM element and create an observable using rx.observable.fromEvent. That's one of their many utilities they provide. And the way it's set up is it takes a DOM element and an event name. It automatically hooks the event name to the DOM element, and every time one of those events fires, it pumps another piece of data through the chain, through the observable. So that's how we create an observable from an event. There's about a dozen or so different ways to make an observable. You can make one by attaching it to an event. You can make a plain old simple observable that you manually are going to pump some data through. You can attach it from, a website. I mean, there's a lot of different ways to make observables. But I make an
Okay. And there's some several ways to create observables. Pull versus push. Observable as generalization of functions. Anatomy of observables here. And this is the overview here. This is the first example here that you got this, right? And here you say, hey, the from event, I want you to pass me is now, okay, the document or the element, and then on any event here, I want to subscribe to that and say, hey, I click. So you can think of this that this is an adapter that hook up on an event source. So an observable is an adapter hooked onto an event source that produces a promise every time that a new event comes through. But it does in a separate way that I can set up my event, source in an entirely different location. I can declare it as what's my data flow. So here we are now, in this case, we are defining this event source, the producer, and then immediately right after is defining what's the data flow. Purity. What makes React powerful is the ability to produce value using pure functions. That means your code is less prone to error. Normally you will create an impure function where other pieces of your code can mess up with your state. The scan operator works just like reducer for arrays. So you say, hey, give me now one single output for this. The return value of callback will then become the next value exposed to the next time the callback runs. You also can define as a flow of data. Has a whole range of operations that help you to control how events flow through your observables. And this is how you will allow at most 1 click per second with plain JavaScript. And this is, you are now attached to the document, and anytime someone click here, it will give you the date.now minus the last click. Alright. If this date.now and last click is greater than the rate, okay, so show the count times here. I think there's some, really? Okay. Oh, this is the plain JavaScript. This is with plain JavaScript. You will have to count is that and the rate to actually see this. This is how you will allow a most. This is how you will allow at most 1 click per second. Exactly. Hey, is this date now? And the last click is greater, all right, than the rate. Okay, good. If it's not, then don't even trigger that or call this. And then you're gonna update last clicks to date now. So anytime you do this, I want you to now update now and update now and update now and so on. But here with RxJs, you say, okay, from event throw time scan, and then you say, hey, I wanna hook up this adapter to the event source, which is in our case the document, to the click event, and then anytime that happens, so we're going to process that by throttle time and scan. You say, hey, throttle time 1,000 seconds or millisecond in this case, scan count, and this is it. So hey, I want you to now increment is the count for this, and then show the count as it is. Other flow control operations are filter, delay, debounce time, take until, distinct, and distill until change. You can transform the value back through your observables. Here's how you can add the current mouse X position for every click in plain JavaScript. But this is interesting, especially the bounce time and the throw time. The bounce and throw. This is now clock in reactive JavaScript or in reactive programming. What is the difference between debounce and throw? And I think this distinction is important, especially if you want to handle this race conditions. So debounce only emits a value after a specific period of time has passed without any new values. Useful when you want to wait for a pause in the incoming value. So I'm gonna wait for this after emit that again. Okay, I'm gonna wait for this after emit that again. And throw say, hey, emits the first value and then ignore subsequent values after a specific time period. Okay, emit the first value and then ignore the subsequent value after a specific time of period. Where now debounce say, hey, emits value after a specific amount. Okay, one focuses on emitting a value after a specific time, debounce. So for example, is great for wait for a pause of incoming values. Okay, so emit a value after a specific amount of time, and the throw says emit the first value and then ignore the subsequent value for a specific time period. So after the time period, I will emit the next value and restart the timer. Useful when you want to limit the rate of emission to a maximum frequency. Useful when you want to wait for a pause in the incoming value. Common use case, search input, where you want to wait until the user stops typing before making an API call. Hey, debounce. Hey, emit a value after a specific time period has passed. Okay. Emit a value after a specific time period has passed. Debounce. And the other is throw. They say, hey, emit the first value and ignore the rest. Okay, and then ignore subsequent values for a specific time. So common use case, window resize events or scroll events when you want to limit the processing frequency. Halt at most every 200 milliseconds while scrolling. Key distinction, debounce, wait for quiet periods, no new value before emitting. So I'm gonna wait for new values emitted by waiting for an X amount of time. And the other is throw, emits. So throw emits immediately, but then enforce a cooldown period before the next emission. Think of debounce like waiting for someone to finish speaking before responding. Okay, while throw is like allowing someone to speak only once every few seconds, regardless of where they are in the middle of a sentence. Okay, throw, hey, you can speak but only once every next amount of seconds. And debounce is like waiting for someone to finish speaking here. Okay, all right, keep going.
Observable on line 1. In an entirely different part of my system, I can declare what all those steps are, what all the calculations of the fields in my spreadsheet look like. Basically, I make a declarative chain of the data flow. So every time an event comes in from the DOM event, every time I click on a button, that's a piece of data coming in, and it's going to flow through this chain. Now, we have utilities that look familiar to us like map. Map in the synchronous sense went over a whole array of values. Map in the asynchronous event is just invoked every time a new piece of data comes along. So you can actually think about an event stream as a never-ending array. And we can perform the same sorts of list operations across time that we would do all together. That's why it was important for us to understand maps and reduces and things like that. So here we can map over an event stream in much the same way conceptually that we could map over an array that was already complete. It's just that every time a piece of data comes through, we can do some sort of transformation on it. And here the transformation is I'm extracting the class name from the event object. Okay. We can filter down. We can perform an exclusion on our list. And that's something interesting, because fundamentally this list is actually asynchronous. We can actually have steps in our response that are asynchronous. Distinct until changed. It's an interesting one. What it says is, the first time a piece of data comes through, let it go through. But if another one comes through with the same piece of data, don't let that go through because I've already seen that one. But then if something new comes along, let that one through. And if I keep getting the same one of those, don't let any more duplicates come through. So let's say I have one that the number 1 comes through the system, and I get 5 of those. Only the first one's going to be let through, and the next 4 are going to be ignored. And then a 2 comes along. So I'm going to let the first 2 come along, and any duplicates are going to be ignored. What happens when another 1 comes along? I'm going to let one more 1 come through, and then ignore any duplicates. That's what the until changed is. So there's distinct, which is just, I only want one ever of the thing, and distinct until changed is distinct, and then I reset. Every time a new value comes in, I reset what I'm remembering. So you notice in this chain, not all of my events are going to make it to line 11. And that's totally okay, because we're setting ourselves up with a data flow, just like we would in a spreadsheet. Subscribe is kind of like the end of the chain. Subscribe is how you basically have a sort of synchronous response to any events that are coming in. So there's more to it than that. But you notice that basically subscribe is kind of like a synchronous thing. I'm not transforming any data. It's not really going to show up in the middle of my chain probably. It's kind of be at the end of my chain. It's when I am finally done with whatever the data is through all of its transformations and filterings, I arrive at some data. So at the end of my chain, I have a subscribe, I have a piece of data that comes in, and I can console.log it out. Okay? So that's a real high-level view of what working with an observable is like. We have to make an observable some way, and we have utilities and libraries that can do that for us, and then we have to respond to observables. And it's appropriate, I think, some people disagree with this, but I think it's appropriate to think of an observable as a stream. It's a stream of data that's going to come through. It's being pumped by a set of events, and it's a stream of data that's coming through. So what about distinct until changed? I actually want you all to pop this up. You have in your slides the link, or you can just type it. I love this website, rxmarbles.com. Let's all take a look at rxmarbles.com. I just get such a kick out of this website. Love this website, rxmarbles.com. Let's all take a look at rxmarbles.com. I just get such a kick out of this website. Let me quickly orient you. Go ahead and click down on the distinct until changed, which is just slightly down the list there on the left. Click on the distinct until changed. And you'll notice that it's depicting for us with these marbles, these little bubbles here, kind of exactly what we're talking about. The stuff on the top is the input, and there's only one stream for this. And the stuff on the bottom is the output. And you'll notice what happens as I start to move these marbles around. What happens if I move this one? And the stuff on the bottom is the output. And you'll notice what happens as I start to move these marbles around. What happens if I move this one over here? You notice how it just disappeared? Because the sequence meant that it was just a duplicate. So we can move the marbles around and see how these different stream operations operate. We're going to come back to Rx marbles and look at more stream operations in a little bit, but you can notice that probably about the top, I'd say maybe 30 or 40 of them are depicted here. Rx actually has probably like 150, maybe 200 different methods. It's a pretty big library. All told, if you got everything, I think it's something like 150, 200K of JavaScript. So it's a pretty stout library. It takes a while to learn all these things. I have not found any other resource on the web that is better at learning than Rx Marbles. I think you can probably learn 50% of observables by doing nothing but just playing around with the bubbles on the screen. It's a really fantastic resource. Okay? Helps you visualize what's happening with your different stream operations. So we'll come back to distinct until chained. I mean, we'll come back to Rx Marbles here in a little bit, but I just wanted to point that out to you. I did say that RxJs is pretty well standardized. It's a really good idea. It's probably a pretty good sense of what we're going to end up with, or something very close to it, if we get observables in JavaScript. I've tried a number of times to learn RxJs. Honestly, I have. And I've never had enough time to get through all of that documentation, the training courses I've gone through. It takes a lot of effort. And comparatively speaking, if I try to analyze the asynchronous event-based coding that I do in my programs, there's actually kind of a small subset of things that I really do on a common basis. So it occurred to me that if I'm already pretty familiar with using asequence for my generators and my promises, why not have reactive programming capabilities within asequence? It actually fits pretty well because I'm already dealing with sequences. That's my abstraction. So all I need to do is be able to make repeatable sequences. And then it fits right in with the same abstractions that I've already created. And all the same methods and utilities that I've got, they all work on reactive as well. So what I did was add reactive sequences to the library. For our purposes, rather than me trying to get you bogged down into learning all the complexities of RxJS, I'm going to show you reactive sequences, which work very, very similarly to the RxJS observables. And I'm actually going to show you that you can transparently go between the two. So you can take a reactive sequence and make an RxJS observable and vice versa.
Well, the size window is
but this is just like, it's like the 5 or 6 most common ones you need put down inside of a tiny little implementation. So instead of having to bring in a 200K library, you get this for like 3K in asequence. So that's really all that's really all it is. Trying to make it a little easier to wrap your brain around.
1 second of debounce call.
So I can make a utility like from event, which looks exactly like the one provided by the observables. It takes a DOM element, takes an event name, and it attaches it. And here I'm using jQuery just to save room on the slides. Of course, we don't have to use jQuery. So that from event utility is how I make an observable. And you see I do that on line 8. Now I'm going to call mine, I use the term reactive sequence instead of observable. I did that on purpose. because it's not an observable. It's isomorphic with observables. They can go back and forth. But it's not an observable. It's my own little thing. It's a much smaller, simpler thing. So rather than calling it an observable and having people complain that it doesn't do exactly the same thing that RxJs observables do, it's a reactive sequence. But it's transparently very similar. So you can go back and forth. So I'm going to call it RSQ just to keep things clear. It's a reactive sequence. And then you'll notice I just start chaining off of it exactly like I do any other A sequence. I can use .vals and .thens and .template looks like. Sequence is to say every 500 milliseconds push some more data down that stream. Each one of those streams I'm going to push some numbers down. So those are starting out at 10 and 11 there on lines 6 and 7. The value's 10.
Mm-hmm. So, all right, okay. So you have now debounce, unlike throw, is that debounce is say, hey, this is pretty much like waiting for someone to speak, okay? Whereas throw is that let someone speak for a few seconds and then interrupt that in the middle of, even in the middle of the sentence. Mm-hmm. Even in the middle of a sentence. Oh, that's great. That's great. Even in the middle of a sentence. Mm-hmm. So this is the difference between debounce and throw. So debounce says, hey, this is like waiting for someone to speak, waiting for someone to finish speaking, or waiting for someone, exactly, waiting for someone to finish speaking before responding. It's like, hey, I'm gonna wait for this X amount before doing that. So can we have an example here? Exactly. How can I check this using GoPaint? Generate step-by-step roadmap to set up GoPaint with RxJs to use to compare debounce and throw functions. Mm-hmm. That's right. Give me to the debounce exactly. Wait for someone to speak. Wait for someone to finish speaking. Exactly. So it's like wait for someone to finish speaking. All right. Wait for someone to finish speaking before responding. That's right. And throw here is that, hey, let speak. Okay, think of throw is allowing someone to speak only every few seconds. So hey, I let you talk about after a few amount of seconds. Okay, this is useful for limiting the useful when you want to limit the rate of emission to a maximum frequency. For example, with scroll that. For example, with scroll that. Okay, let's get into this because this piece of code I think is quite interesting here. Let's get into this. It's going to define now here our new pen. Okay, that's right. You have the container, style, head, the body. We actually close the body here. And similar for the HTML. Okay. And now I want to see if I can get that value here, because oh, there is no need to actually indicate that, but browsers needs to say, hey, we are about to use is an HTML5. Perhaps not right now, but browsers need that. So this environment doesn't need that, but we know the browser actually need that. And we are going to get that GSX. So we say, hey, I want you to import RxJs, okay, from here, and get me the RxJs, and I want to console log that RxJs. Okay, so if I hit here, the specifier RxJs was very specified but was not remapped to anything. Relative model specifier must start with this. But actually I am importing that. Actually I am importing that. So it means that so you expose that as a global object, maybe here. So for example, if I do this, can I have access to that? Exactly. I can have access to that through RxJs. So this is what is exposed, and this is what is mounting that. So you can see the window.rx, and as you can see, this actually is mounted into the window object, right? Which is the play of how you can now in JavaScript access or to define all of these functions. Okay. Okay. All right. Okay. So we import that. All right. And we're going to now is actually make use of the from events and the operators here. So as you can see here, we are looking at the notification kind and the operators, where we can get all of it: audit buffer, audit time, buffer count, buffer time, and okay. So here we say, hey, please, it's going to get now the from events from the observable and create that for us, right? Where you say this is the bound input, throw input, all right? They have this function called log with time that is going to get that element, okay, and then show that into that. They use is inner HTML. We can use is, instead of inner HTML, we can go with they create elements, which is a helper function to log that. So instead of doing this, right, we just say, hey, log with time, instead of inner HTML, we can say text content for that. This is an element here. I want to get the text content here. All right. And the text content will be now this. So whatever you have in the log entry, all right. And then there you go. So after that, all right, this is the way of how it generates that code. I'm not a big fan of this. And here is when you say, hey, set up the debounce example, debounce input and throw input. And here is when you are actually is getting that. Hey, the debounce input. Say, hey, debounce input is document get element by ID, all right, where you say, hey, what is the ID of this element? Is this thing is the bound log? No, the bounce input, all right. And now I want to actually subscribe to that, where you say, hey, from event, I'm gonna pass now the input. I'm gonna pass this event source, the bounce input, followed by the transformations here. Okay. Okay. So the event source followed by the event source followed by the event that I want to listen. In this case is the input. And then what I do is, well, I'm going to use now this pipe as a way to pass this input. So as a way to pass the input, as a way to pass now the transformations from the inputs to an output to the next method, as a way to have a change of calculations, a change of fields like in a spreadsheet. So here we say this is pipe, right? And we're gonna now apply is the transformations that we want to apply to each individual events that come from the event source, which is in this case is map. Okay. Hey, get me is the target from that event.target, and we say target because this is the element who cast this. All right. The element who emit that event dot value, and then now the debounce here, debounce time, which we're saying, hey, after the next, I want to know allow you. So let somebody finish speaking before you respond. So this is useful for wait for something. In this case, wait for something on the input, like this. When you say, hey, this is the debounce, it's gonna accept. If we need to actually take a look at that, for example, here with the bounce time. We also might use this debounce here with Lodash. Create a debounce function that delays invoking function until after wait millisecond, have a lasted. The debounce function comes with a cancel method to cancel delay function invocation. Exactly, but this is you're gonna use inside of that functions. New event source, and then you say, hey, debounce this, and apply this batch function here after the next amount of time. Exactly. Sure, the batch log is invoked after 1 second of the bounce call, but because we are using this Rx here, like this. Exactly. We need to pass this the due time and the scheduler. All right, but again, let's go to make our life simple, which is 1000. So hey, after 1000 seconds, I'm going to now is to, well, subscribe to this and do something. And do something here. And in this case, I'm gonna get the value here, which is value. All right. I'm gonna get the value, and I want to now is call that function. Call this function, right? That is log with time debounce. Say, hey, debounce it, and the value as expected. And the value as expected. So now this is already attached to that. Okay. So debounce will work as expected. Say, hey, oh, because we are oh, I get it. Now what we can do is that anytime we do this, all right, log entry like so, I want to create now a new element for that. They say, hey, this is the log element here, right? I want to create now a new element on the log element here, which is log element because it's appending all of that. I get it. Log element, new log element here. You say, hey, document.create element as a div, right? And then right after that, what I want to do is to say new log here will be this, and I want to now append that right below. So log element here, append child with the new log element, right? Pretty much that's it. So it's going to now, after 1 millisecond, after I stop you, after I let you finish talking, all right, then you gotta debounce that. It's a value defined. That's quite interesting. Oh, exactly, because it's only log entry. That's right, and then you got it. And that's pretty interesting here. So debounce with RxJs. All right. So that'll be all for this video. Take care. Bye-bye.